Hello students, welcome back to my channel. In today's session, we will be learning once again another type of a sorting algorithm, and this is going to be insertion sort. So we have seen different types of sorting algorithm in the previous session, and today's sorting algorithm is nothing but insertion sort. And just like any other sorting algorithm, this is going to arrange the given element in a certain way, either in a descending or an ascending order. And here we will be using the insertion method. So hence the name insertion sort. So let us go ahead and see what exactly this algorithm does and how it is different. Okay. So insertion sort is a simple intuitive sorting algorithm that builds a final sorted array one item at a time. Okay. It is particularly efficient for small data sets or nearly sorted data. Okay. So think of it like a sorting a hand of playing cards. Like many of you would have played this here. If you're arranging it in a certain way, a card, if you have to arrange it in a certain way, initially you would have had in a certain set in a certain disordered way. So what you will do is you will go through each of the cards, and as and when you get a number, you will remove this and push it in a particular place. Okay, that is what nothing but you're inserting in its appropriate place. The same methodology is used when it comes to the insertion sort. So you pick up one card at a time and insert it into its correct position among the cards which is already there in your hand. Okay, so this is how our insertion sort works. Here, instead of a card, we are going to have numbers. So let us see how it works. First, we will have the first element is considered sorted. As in, suppose I have the number 10, 23, 8, and I will take 1. I will take initially the first number as this is sorted, or I will take it as a key. After that, I'm going to iteratively comparison is what I'm going to perform. So each subsequent element is picked and compared with the element in the sorted portion that I'm going to take this element and I'm going to compare it. Now, obviously, this is in a sorted way, so I'm not going to touch it. So I will consider in the next phase that this is the sorted and this is the unsorted. I will take the next element and I'll compare. Now, as you can see, 8 is of course it is smaller than 23, hence I am going to uh, now I need to find out which is the appropriate position. Now I am going to move this 8, but I do not know that this is the correct position. Maybe the next element is also greater. That is why I'm going to check the next element. And as you can see, of course, 10 is also greater. Hence, next time I'm checking, there is no more element, which means this is going to be the appropriate place for 8. And hence, I'm going to place 8 over here by pushing these two elements to the other side. Similarly, I will compare this. Now, as you can see, this 8, 10, 23 is a sorted portion. I'm going to take the next element and compare and find out which is the correct position for it to be inserted. So I'm going to find out the position and then insert it just like how we do it in a card. So this will happen during the iterative comparison. So once I find the position, elements larger than the picked element are shifted one position to the right. So every time I'm finding, for example, this 8 itself, if I'm finding that I need to push here, I will push 23 to the 8th position. I will push 10 to the 23rd position and I will insert at 8 in the beginning. Okay. So once the picked element is inserted into its correct position in the sorted part. So this is how a insertion sort works. Let us go ahead and see the algorithm. So before that, let us see one illustrative example for sorting the numbers. So in this example, we have an array where the values are 5, 2, 4, 6, 1, and 3. So initially, I'm going to take 5 as a sorted. I'm assuming that this is sorted, and I will take 2 and I will compare. And I find that 2 is smaller than 5, hence I'm going to push 5 this side and I'm going to insert 2 here. That is why in the next pass, I'm going to have this. Now, next element is picked as a key, and then I'm going to compare it with the next element. That is 4 will be compared with 5 and 4 will also be compared with 2. But then since the 4 is coming between 2 and 5 in the next phase, as you can see, 2, 4 and 5 are in ordered set. Next, Next, I'm going to pick the next element and then I'm going to compare in a similar way. As you can see that there is no need of change as it is in a sorted way. So hence I'm going to consider till here it is a sorted. And then next I will compare 1. As I can see that 1 is lesser than 6. It is also lesser than 5. It is also lesser than 4 and it is also lesser than 2. And the correct position is going to be this one. Hence 6 will be pushed over here, 5 will be pushed over here, 4 will be pushed here, 2 will be pushed here, and 1 will be inserted. And the last element, 3, when I'm comparing, I find that it is lesser than 6, it is lesser than 5, it is lesser than 3, but it is greater than 2. Hence, the correct position is here. Only 6, 5, and 4 will be pushed here. And in the position of 4, we are going to insert 3, and then we are going to get our sorted array. So, this is how insertion sort works. Okay. So, let us go ahead and see the algorithm. So this is the algorithm. As you can see, initially this I am going to take, which is going to be from 1 to length of a minus 1. So here we are nothing but we are going to take the values. So as you can, we all know that array starts with 0, but I'm not taking the 0th element. Instead, I'm starting from 1, as in from the next element onwards, I'm going to take. And then key I'm going to say as a of I. That is the very first element is going to be the key because I want to compare. Key is nothing but the value which I am going to find its position. So that is nothing but the key. And j is going to be I minus 1. J is always going to be the previous element. So this is nothing but the previous element with which I am going to compare my to be inserted element, which is nothing but key. Okay, so that this portion is for that. Now inside this for loop itself, we have another while loop. This is nothing but what this does is it is going to compare this particular key with all the values and then it is going to find out the position where it has to be inserted. All right. Now we will quickly go through one example and we will iterate this and we'll see that time it will be clear. So I want all of you to write this down in one paper so that in the next page you can take one example and iterate it in C. All right. So I hope you have written it down. So let us start. So initially this is my example where I have these values. So what happens? The very first step is I'm going to start my for loop, which is the I value is going to start from 1 to length of the array minus 1. So length of the array is nothing but here it is 5. 5 minus 1 is nothing but 4, which means my for loop is going to run from 1 to 4. And key is nothing but I'm going to take a of I. So a of I is nothing but a of 1, which is nothing but initially I'm going to take 1 as a key value. So my key value is initially 1. Remember, this is the initial, this is the first pass. This is the first pass we are doing. And j value is going to be I minus 1, which is nothing but once again, I value is initially 1, I minus 1 is nothing but 0, which means this is going to be my j value. All right. So now, next we are going to the while loop. Now, while j is greater than or equal to 0, so j value, as we all know, j is nothing but 0, and it is greater than or equal to 0, equal to is satisfying. Also, we have another condition that a of j value should be greater than key. Now, what is my a of j value? A of j value is nothing but 23, and key value is nothing but 1. Hence, what is happening is the j value, that is the initial value which I've assumed that it is sorted, is now greater than the key value. So whenever it is true, what I'm going to do is a of j plus 1. Now remember, the moment we find a value which is smaller, we need to push it this side. The value has to be pushed this side, and I have to insert this value. So I'm going to say that a of j plus 1. J plus 1 is nothing but this position is going to get the value of a of j. So what is a of j? A of j is nothing but 23, which means now I am going to push the value. As you can see here, I am going to push 23 to a of j plus 1. And then next I am going to say j is equal to j minus 1, which is nothing but now, since it is 0, now it is going to be minus 1. I am reducing the value. You'll understand why we are doing that. And then I will say that once again, a of j plus 1 is equals to key. After reducing minus 2 minus 1, now a of j plus 1, when I say it is nothing but a of 0, and a of 0 is going to get the value of key, and a of 0 is nothing but this one, which is the very first position, and then the key value had value 1 that I'm going to insert over here. As you can see, this is done. So that is what we are doing. Like I told you, here for loop is nothing but in order to find out which is the value which is sorted, and from there, I'll assume the value is sorted. From there, we are going to take each one of the values and then we are going to compare it with the sorted value. Okay, key is nothing but the value which has to be inserted. So we need to find the position for that. That work is done in the while loop, where we are going to compare the value of j with the key, and then we'll find out if it is greater, then we are going to push it. The pushing happens over here, and then we will insert it. Insertion is happening over here. Okay, so this is the very first iteration. Now what happens next? We are not going to terminate here. Remember, now I had a j value as -1. Once again, we will go back to the while loop and I will check that, check the condition whether j is greater than or equal to 0. But in our case, j is -1, hence this will terminate. All right. So once the while loop is terminated, we are going to go back to the for loop. That is where our second pass will start. So in the second pass, what is going to happen is, second pass, I loop is going to get incremented to 2. Now I value as and when it is going to get incremented, key is going to be a of I, which is nothing but a of 2, and a of 2 is nothing but 10. So now I'm assuming that these two are sorted. I will start, pick the next element, and now I need to find the correct position for that. So key is nothing but 10. J value is nothing but I minus 1, which is nothing but 1. Now j value is going to be 1. Once again, check. While 1 is greater than or equal to 0, this is true. And we have to check that a of j. A of j is nothing but a of 1. And what is a of 1? A of 1 is nothing but 23. Is this greater than the key value? These two conditions should satisfy. Yes, in our case, this 23 is greater than the element which we are trying to insert. Hence, what we are going to do, once again, we are going to do this. So, a of j plus 1. J is 1. So, a of 2 is going to be equal to a of 1. So, where do I have a of 2? This is nothing but a of 2. This is the position. So in the a of 2, I am going to insert the value 23. So as you can see, once again, I have pushed the value to the next. After that, what I'm going to do is reduce the j value -1. So j value is going to be 0 now. And once again, I'm going to say that a of j plus 1, which is nothing but a of 1, is going to get the value of key. Okay, so as you can see, key value is inserted here. Now we are not going to once again stop here. Once again, while loop will come back. Now the j value has become 0. I will check that 0 is greater than or equal to 0 satisfied. And I'm also going to check if a of j is greater than the key. Now what is the a of j value? A of j is nothing but a of 0. A of 0 is 1. But 1 is not greater than 10. Hence this will become false. Hence we will terminate from the while loop. Okay. And hence we will go to the third pass, and the third pass is nothing but where I have I value is incremented to 3. I hope it is clear. All right. So now I value is incremented to 3. Now key value is nothing but a of I, which is nothing but a of 3. And what do I have in a of 3? So this is 0, 1, 2, 3. This is nothing but a. Sorry, 5. So 5 is going to be the key value. And j is nothing but I minus 1, which is nothing but 2. Now, once again, check the while condition. J is greater than or equal to 0, true, and a of j. So, a of j, I have 5 is, sorry, a of j is 2, so 23. Is 23 greater than the key value? Yes, this is also true. Both the conditions are true. Hence, now we are going to push the value. So what I'm going to say, a of j plus 1, which is nothing but 3. A of 3 is going to be equal to a of 2. Let us see what is going to happen. So a of 3, third position is going to get the value of a of 3, which means I'm once again pushing the 23 this side. And then j value is going to be reduced to 1. And then a of j plus 1, which is a of 2, is going to get the value of key, which is nothing but 5. So a of 2 is going to get the value 2. So initially it is going to get the value 2 is going to be here, and 10. Okay, let me just write it here. So understand here what is happening. So 23 will be pushed here, over here, and 5 is here as of now. Okay. So now what is going to happen? Let me change the color. 5 is here, 23 is moved here during the first iteration. Once again, we'll come back to the while loop, and now j value is 1. Once again, I'm checking whether 1 is greater than or equal to 0. This is true. And also checking now a of j. Now, what is the j value? J value is 1. A of j is nothing but 10. Is 10 greater than 5? Yes, this is also true, which means this is not the correct position. So once again, what we will do, a of 2 is equals to a of 1. So what is a of 2? A of 2 will be moved to a of a of 1 will be moved to a of 2, j will be reduced to 0, and a of 1 will get the value of a of I. So as you can see, a of I is being pushed here. So what exactly we did? So we had 1, 10, 23, and 5. So in the first while loop, we got 5 over here, 23 over here, 10 was here, and 1 was here. In the next j value, when we reduced once again to 0, what happens is again we are comparing this value with this because it is necessary. We can't just push one value, one position and say that it has reached the correct position. We need to check if the previous value is also greater. All right, so that is what we did. So when we are checking, we found out that 10 is greater than 5. Hence, once again, we did that entire shifting. And then now, after the completion, this is how our array is sorted. So as you can see, by the time of completion of the fourth pass, this is how my array will be looking like. All right. So once again, now we will not stop here. When we complete this, j has reached 0. Once again, I'm going to come here. J is 0, which satisfies the condition. And in the 0th position, I have 1. But 1 is greater than 5. This will fail. Hence, we will stop the execution. And we will end up with this particular array after the completion of third pass. Now going to the fourth pass, I value will become 4. Key is equals to a of 4, which is nothing but a of 4. We have key value is 2. And then j value is nothing but I minus 1, which is nothing but 3. Now we will go to the while j should be greater than or equal to 0, and our condition is a of j. A of j is nothing but a of 3, which is 23. It should be, is it greater than the key value? Yes, this is also true in this case. So when both the conditions are true, what we are going to do is a of j plus 1, which is nothing but 4, is going to get the value of a of j of a of 3, which is nothing but I have to push this over here and this will be pushed over here. Okay, 23 will be pushed over here and j value I'm going to reduce it to 2 and I'm going to say that a of 3 is equals to key. So when I complete this, these two values are exchanged. Okay, so this is initially 2 and yeah, this is initially 2 and we have 10 here. Next, what we are going to do once again, now j value is 2. I'm going to compare whether 2 is greater than or equal to 0. Yes, it is true. And I'm going to say that whether a of 2. Now, what do I have in a of 2? I have 10. Is 10 greater than 2? This is also true. Hence, what I'm going to do is, so this was the first value. This is the second time. A of 3 is going to get the value of a of 2. So what do I have? Instead of this 10, so initially I had 2 over here. So 2 will be moved here and 10 will be moved here. Okay, so I have what I've done now initially. Let me write somewhere else. So initial was 1, 5, 10, 23, and 2. Initially, when j was 3, what happened is 1, 5, 10, 2 was moved here, 23 was moved here. Next, when j is equals to 2, what is going to happen? We are comparing this with the previous element and we are finding out that that is once again greater. Hence, I am going to push it over here, 23. Similarly, now what I'm going to do is I'm going to reduce the value of j to 1. This condition will become true. And what do I have at a of 1? I have a of 1, 5. So 5 is once again greater than 2. Once again, I need to do this. As in, what I will do is I will bring 2 over here, 5 will be brought here, 10 will be brought here, and 23 will be brought here. All right. Once again, j value will be reduced to 0 and 0 will come here. 0 is greater than or equal to 0. Yes, it is true. But in the 0th position, I have 1 and 1 is not greater than 2, hence which means it has reached its correct position. All right. In the fifth pass, what is going to happen is I value is going to get incremented to 5. But remember, our condition fails here. Hence, we will terminate the algorithm. So this is how insertion sort works. It's very simple code provided you understand how it works. It's a neat code and very easy to understand. I hope I am able to make it clear to you. All right. So what are the key takeaways of insertion sort? It is very simple, like I told you, it is easy to understand and implement. It is very efficient for small data and it sorts array without requiring additional memory space. That is also important. Whatever array we have within that itself, we can do the insertion sort. Research its time and space complexity and compare it with the other basic sorting algorithms like bubble sort and selection sort. This is work I'm going to give it to you. So we have already discussed the bubble sort and selection sort. Now, how do we calculate the time complexity? You can make a comparison table and then we can discuss on how it is better than them, whether it is whether other algorithms are better or this is better. All that comparison you can do. So once I'll complete all the sorting algorithms, of course, I'm going to discuss all this. But as of now, you have to do this. All right. I hope today's session was clear. So that's all in today's session. I hope you people are finding it informative. So thank you for watching. Keep learning.